Welcome to math classes. Today we'll see some critical questions from binomial theorem. Mostly they are PYQs from JEE mains. Okay, let's get into that. Fourth term of given expression is equal to 200 and x is greater than 1. Then what is the value of x? Okay, so this is simple. This is looks like a plus b whole to the power of 6 and we need fourth term. Correct? Fourth term means tr plus 1 is r plus 1 is 4, so r is 3. Correct? So 6c3 is the quotient. Correct? So t4 is nothing but 6c3. Okay, and 1 by x to the power of 1 plus log 10 x whole to the power of half because it is square root. Okay, and to the power of 6 minus 3 and x to the power of 1 by 12 whole to the power of 3. Okay, this is my t4. Now it's all about simplification. Correct? So if I simplify it, 6c3 is 20 and then this will become 20 times x to the power of 3 by 2 times 1 plus log x to the base 10 plus 1 by 4, which is equal to 200. That is what is given. Okay, so now if we simplify 220, the RHS side it will become 10. Okay, so 10 equal to x to the power of 6 plus 1 plus log x divided by 4 times 1 plus log x. Okay, now this is if you want to get the value of x, we need to apply log. So apply logarithm on both sides. You will get 7 plus log x divided by 4 plus 4 log x into log x equal to 1, or you can take log x as k, then it will become 4 plus 4k equal to 7k plus k squared, or you get a quadratic equation in k which is k squared plus 3k minus 4 equal to 0. So k is either 1 or minus 4 and k is nothing but log x. So log x is 1 or minus 4, which means x is 10 or 1 by 10 to the power of 4, and it is given in the question that x is greater than 1. So in this case x is 10. That's the answer. Next, let a be the sum of all quotients of 1 minus 2x plus 2x square whole to the power of 2023 into 3 minus 4x square plus 2x cube whole to the power of 2024, and b is nothing but limit x tends to 0 integration of 0 to x from 0 to x log of 1 plus t divided by t to the power of 2024 plus 1 dt divided by x square. If the equation cx square plus dx plus c equal to 0 and 2bx square plus ax plus 4 have common root, then what is d is to c is to e? Okay, so basically you need to find ab values. Okay, from the quadratic equation find the roots. Okay, and if these are the common roots with cx square plus dx plus e, then we have to guess what is the ratios. Okay, so first part is simple. Sum of coefficients is very simple. We just need to substitute x equal to 1, then you will get sum of coefficients. Correct? Very easy. Okay, so sum of coefficients of the given expression is, if I substitute x equal to 1, I get 1 to the power of 2023, okay, into 3 minus 4 plus 2, which is also 1. So 1 to the power of 2024, which is 1 into 1, that is 1. Okay, so a is 1. Okay, now second part, b is equal to limit x tends to 0 integration of this value dt divided by x square. Okay, now if I substitute x equal to 0, what happens? If I substitute x equal to 0, this integration will become 0 to 0, and this expression, which is obviously will become 0. So 0 by 0 form it is. Okay, so now we can apply L'Hospital rule. That means differentiate numerator and denominator. Okay, so if I differentiate the denominator, x square will become 1 by 2x, and the numerator integration will go off. And in terms of t, it will become x because it is up to x. Correct? So log of 1 plus x divided by x to the power of 2024 plus 1 into 1 by 2x. Okay, limit x tends to 0, of course. Okay, so this I am rearranging the words in such a way that log of 1 plus x by x into 1 by 2 into x to the power of 2024 plus 1. Now we know that this is limit x tends to 0, log of 1 plus x by x is 1. Okay, now here if I substitute x equal to 0, this will become 1 by 2. So the whole limit is 1 by 2. This is what b. Okay, a is 1, b is 1 by 2. Now if I substitute, my 2bx square plus ax plus 4 is nothing but x square plus x plus 4, which is equal to 0. If you see the discriminant or determinant is square root of minus 15, which means they have only complex roots. Correct? It has only complex roots. And we know that when a quadratic equation has complex roots, it will have the complex root and its conjugate also. Okay, so which means the two roots are fixed. Correct? And if another expression, another quadratic expression, which is cx square plus dx plus e equal to 0 has one common root, it also should have one more common root also. Both conjugates, both the complex number and its conjugate, both should be roots of cx square plus dx plus e also. Okay, correct. So which means the roots are common between these two, which means these two expressions are exactly same. It has to be exactly same to get the same complex numbers and its conjugate, right? So d is to c is to e is nothing but 1 is to 1 is to 4. Okay, just to don't get confused, d is here. D is to c is to e is same as 1 is to 1 is to 4. Okay, so that's the answer. Next.
Struggling with Maths Olympiad or Engineering Entrance Prep? Let's make it simple. Welcome to Fun with Mathematics, your YouTube hub for mastering IOQM, JEE, and BITSAT with clarity and confidence. For Olympiad aspirants, we dive deep into number theory, geometry, polynomials, recursive functions, and more, with daily practice problems and complete solutions to previous year IOQM papers. And if you're gearing up for JEE or BITSAT, we've got you covered, with full cert classes for 11 and 12, solved exercises, and past year questions across topics like trigonometry, complex numbers, calculus, probability, and statistics. Every concept is broken down with tricks, trades, and visual clarity, so you don't just memorize, you understand. Whether it's sets and relations or the binomial theorem, we simplify the toughest topics and help you build real problem-solving power. Subscribe now at youtube.com/@psk99999 and let's make math your strength.
Let a plus bx plus cx square whole to the power of 10 equal to sigma I equal to 0 to 20 pi times xi. Okay, where a, b, c are natural numbers. If p1 is equal to 20 and p2 equal to 210, then what's the value of 2 times a plus b plus c? So the notation looks very odd actually. So to just try to understand, it is very simple question. Okay, one side you have a multinomial expression a plus bx plus cx square whole to the power of 10, correct? At this side you have expansion of it. This is nothing but the expansion of this. You have I running from 0 to 20, which means here also the x terms will have power from 0 to 20, correct? So here also you have from 0 to 20 x to the power and some pi. So which means pi is nothing but coefficient of x term. Okay, p1 is coefficient of x, p2 is coefficient of x square. That's all it is. Okay, so let's solve it using the multinomial formula, which you should remember. Okay, this is very useful formula. Okay, for a multinomial formula, the expansion of if you take to the power of n also, 10 will become n basically. That's the only difference. Okay, it is sigma k plus l plus m equal to 10. Then 10 factorial by k factorial, l factorial, m factorial into first term a to the power of k, second term bx whole to the power of l, and cx square whole to the power of m. Okay, this is your expansion basically. Okay, now I am interested in p1. P1 is nothing but x coefficient of x, correct? So coefficient of x means I should get only x in this. How it is possible? Okay, x is possible if x square should not be there, so m should be equal to 0. Okay, and x should be there, so l is 1, and the remaining is k plus l plus m should be 10. So this is 0, this is 1, so k should be 9. That's it. Okay, so for p1 is the quotient of x, which means l equal to 1, k equal to 9, and m equal to 0. Once you know this one, p1 is nothing but 10 factorial by 9 factorial into 1 factorial into a to the power of 9, b to the power of 1, and c to the power of 0, which is equal to 20. If I simplify this, I get 10 times a to the power of 9b equal to 20, or a to the power of 9b equal to 2. Okay, now you look at a, b, c are natural numbers. Okay, so the only option possible here is b should be 2, b should be 2, a should be 1. That's the only option. There is no other option possible. Okay, so a is 1, b is 2. Now x square, let's take p2 is quotient of x square. Now x square is possible in two ways. One is l can be 2, m is 0, and k is 8. That is one option. L can be 2, k is 8, m is 0. Or m can be 1. Okay, then I have the x square here. M is 1, l is 0, k is 9. K is 9, m is 1, l is 0. Okay, so these are the two options I have. So p2 is sum of these two basically. So p2 is nothing but 10 factorial by 9 factorial into 1 factorial into a to the power of 9, b to the power of 0 into c to the power of 1 plus 10 factorial by 8 factorial into 2 factorial, a to the power of 8 into b square into c to the power of 0, which is equal to 210. You simplify the same way. Okay, you will get this expression here. Now I need to substitute a equal to 1 and b equal to 2. correct? If I substitute this one, I get c equal to 3. Okay, you can do the substitution and do simplification. You will get c equal to 3. Now I have my a, b, c, all values are there. A equal to 1, b equal to 2, c equal to 3. So 2 times a plus b plus c is nothing but 12. That's the answer. Next. The sum of quotients of 3 consecutive terms in the binomial expression 1 plus x whole to the power of n plus 2, which is in the ratio of 1 plus 3 is to 5 is. Okay, so basically you need to find out the sum of quotients of 3 consecutive terms. Okay, who are in the ratio of 1 is to 3 is to 5. Okay, so we'll take tr plus 1 and tr plus 2 are the 3 consecutive terms. Okay, the quotients are n plus 2 cr minus 1, n plus 2 cr, and n plus 2 ca r plus 1. Now since the ratio is given 1 is to 3 is to 5, you take 2 terms at a time. First I am taking n plus 2 cr minus 1 divided with n plus 2 cr, which is equal to 1 by 3. Correct? Now expand it. Okay, n plus 2 factorial on the numerator for both of them, so they get cancelled. So only denominator I am worried. So denominator, because it is the denominator of this term will go here. Okay, and denominator of this term, okay, n plus 2 cr will go to the numerator. Correct? So first thing is denominator of this one is r factorial into n plus 2 minus r factorial, which is here. Okay, and the denominator of this one is r minus 1 factorial into n plus 2 minus r plus 1 factorial. Okay, this is nothing but, if I simplify, r factorial by r minus 1 factorial, so I am left with r here in the numerator, and this is n plus 3 minus r, n plus 2 minus r, so I am left with n plus 3 minus r. Okay, factorial, rest of the terms gets cancelled, which is equal to 1 by 3, which means 4r minus n equal to 3 if I simplify. Okay, this is my first equation, and take the other two ratios, n plus 2 cr, 2 n plus 2 cr plus 1 is equal to 3 by 5. Same way you expand it, and you will be left with r plus 1 divided by n plus 2 minus r, which is 3 by 5, or 8r minus 3n equal to 1. Now you have two equations, two variables, you can solve them. You will get n equal to 5 and r equal to 2. So the three consecutive coefficients are nothing but 7 c2, 7c1, 7c2, and 7c3. Okay, these are the three terms. Now all I need is sum of quotients. So 7c1 plus 7c2 plus 7c3 is nothing but 63. That's the answer. Next. Let x equal to 8 square root of 3 plus 13 whole to the power of 13, and y equal to 7 square root 2 plus 9 whole to the power of 9. If square bracket t denotes the GIF, okay, greatest integer function, then which option is correct? Okay, so first thing is you need to find out GIF of x and GIF of y. Okay, now this is one very complex question, came in JEE mains actually 2023. Unless you have the idea of solving this by taking the conjugate of each of these expansions, you cannot solve this problem that easily. Okay, so the way to solve this problem is, we know 8 square root of 3 plus 13 is there, and you take the conjugate of this one. Okay, so if you take 8 square root of 3 minus 13, which is conjugate of this one, okay, approximate value is around 8 into 1.732 minus 13, which is around 0.853, which is less than 1. Okay, so now if I take 8 square root of 3 minus 13 whole to the power of 13, obviously this will be less than 1. Okay, because the inside value, its base value itself is less than 1, so to the power of 13 it will be less than 1 only. Okay, now once you know this one, okay, let's call GIF of x plus some fraction of f, okay, which is expansion of this one, right? X is nothing but I can write it as GIF of x integral value plus fractional value, correct? So integral value plus fractional value, which is equal to 8 square root of 3 plus 13 whole to the power of 13. If I expand, this is how it looks like. 13c0, 8 square root of 3 whole to the power of 13, 13c1, 8 square root of 3 whole to the power of 12 into 13, and so on. Okay, power of 8 square root of 3 will go down, power of 13 will increase, and finally I am left with 13c3, 13 to the power of 13. Correct? Now, what is my conjugate to the power of 13? Okay, which is f. I will get only fractional part, because we already know this is less than 0. So to the power of 13 also less than 0. So only fractional part equal to 8 square root of 3 minus 13 whole to the power of 13, which is equal to 13c0, 8 square root of 3 whole to the power of 13 minus every alternate term here will be minus. Okay, now if I add these two, what happens? Subtract these two. If I subtract these two, I'll get GIF of x plus f minus capital F, which is nothing but 2 times I am left with these values. whichever is negative here, I'm left with 2 times of these values. These values gets cancelled. Other values get alternate terms gets cancelled. So I'm left with 2 times 13c1 8 square root of 3 whole to the power of 12 into 13 plus 13c3 because alternate term, right? This is 1, then 3, 13c3 8 square root of 3 whole to the power of 10, 13 cube up to 13c3 13 to the power of 13. Now if you see clearly, every 8 square root of 3 term has even power, okay, up to 2 and then it will be 0, and here there is no 8 square root of 3 term. So every term in this expansion is a integer. Every term in this one is a integer. So this whole expression is 2 times integer. Okay, that means this fractional values gets cancelled by each other. This fractional value is out. Okay, only you are left with gif of x, which is nothing but 2 times integer, that is even number. Okay, now exactly same thing you can do with the 7 square root of 2 minus 9. Okay, take this conjugate of the 7 square root 2 plus 9, which is also less than 1. So if you take to the power, it is less than 9. Exactly same thing I will run here. gif of y plus f1 is this expansion here, and capital F1 is this expansion here of the conjugate. Okay, subtract both of them. gif of y plus f1 minus f1, which is equal to 2 times this expansion, and here every term will be integer because to the power of even number, every term is an integer, so it is 2 times integers. So gif of y is even number. So now we know that gif of x is even, gif of y is even. So which option is correct? A is wrong because gif of x is odd, he said. Gif of x and y are odd, wrong. Gif of x is even but y is odd, this is also wrong. Gif of x plus gif of y is even, yeah, this is true because both are even anyway, some of them also even. So option sorry, not B, this is option D. Okay, option D is correct. Okay, next. If AR is the quotient of x to the power of 10 minus r in the binomial expansion of 1 plus x whole to the power of 10, then sigma r equal to 1 to r cube AR by AR minus 1 whole square equal to how much? Okay, so this is simple. AR is nothing but quotient of x to the power of 10 minus r, correct? So how do you get x to the power of 10 minus r? If I write this instead of 1 plus x whole to the power of 10, if I write x plus 1 whole to the power of 10, it is very simple, correct? So quotient of x to the power of 10 minus r in 1 plus x whole to the power of 10 is same as quotient of x to the power of 10 minus r in x plus 1 whole to the power of 10, correct? So this is here. This is simple. Quotient of this one is nothing but NCR, correct? NCR. So AR equal to NCR, AR minus 1 is NCR minus 1. The ratio of these two, AR by AR minus 1, is nothing but NCR by NCR minus 1. Okay, n factorial on both numerators gets cancelled, so I am left with only these terms. If I simplify it, n equal to 10, so 11 minus r by r. Okay, so now in this expression, this is 11 minus r by r, correct? Now you substitute it there. Okay, substitute it, you will get 11 minus r whole square into r, because r cube and by r square, so I'll get r here. If I expand it, this is what it is. Sigma r equal to 1 to 10 r cube minus 22 r square plus 121 r. Okay, now this is sum of first 10 cubes of integers. Okay, sum of cubes of first 10 integers, which is nothing but n into n plus 1 by 2 whole to the whole square. This is the formula. Okay, so I substituted n equal to 10. This is the formula. Minus 22 times sum of first squares of first 10 integers. Okay, which is n into n plus 1 into 2n plus 1 divided by 6. Okay, n equal to 10. So this is the formula. Plus 121 times sum of first 10 integers, which is 10 into 11, n into n plus 1 by 2, 10 into 11 by 2. Okay, now it's just a matter of simplification. If you simplify, what you will get is 1210. That's the answer. Next, sigma r equal to 0 to 22, 22 cr into 23 cr equal to how much? Okay, this is one more interesting problem came in JEE 2023. You need to understand how to solve such problems. Okay, there is one more question actually in JEE 2023. You can see my charts actually. In the charts I have put, but here I am trying to solve that how you get that formula basically. Okay, there I just used it, but here I will almost to derive the formula for a common thing. Okay, so how you do this problem is, first you try to understand 22 CR and 23 CR, correct? And R is running from 0 to 22. Means it has actually all the quotients of 22 CR, okay, because there are 23 terms will be there. But whereas if you take 23 CR, Okay, that is 1 plus x whole to the power of 23. All the coefficients, there is one short, correct? Because you are equating to the 1 plus x whole to the power of 22 coefficients, okay, and product with that. And if you see sigma r equal to 0 to 22, 22 cr, 23 cr is nothing but same as sigma r equal to 0 to 22, 22 cr as is I wrote, and 23 cr I am writing it as 23 c 23 minus r, 23 c 23 minus r. Okay, if I expand this one, it is nothing but 22 c0, because 23 c 23 minus r is same as 23 cr, correct? So if I expand it, I'll get 22 c0, 23 c 23, 22 c1, 23 c 22. Okay, so 23 cr is decreasing in the r value, 22 cr is increasing in the r value. Okay, correct? And everywhere if you see the sum of r values, if you call this r1, this you call it r2, sum of this is 23 everywhere, sum of this is 23 everywhere. Okay, now once you know this one, this problem is very simple. Okay, how it is simple? I am looking at basically x to the power of 23 quotient from some expression. What is this expression? Let's form it. Okay, we know that 1 plus x whole to the power of 22 is nothing but 22c0 plus 22c1x plus 22c2x square up to 22c22x to the power of 22, correct? Same thing, 1 plus x whole to the power of 23 is 23c0 plus 23c1x up to 23c23x to the power of 23, correct? These are the expansions of these two. Now if I multiply these two on the LHS side, 1 plus x whole to the power of 22 and 1 plus x whole to the power of 23, and then find out x to the power of 23 quotient. Why x to the power of 23? If you look at here, the sum of this one is 23 is coming. So I am looking at 23 quotient of x to the power of 23. Okay, so quotient of x to the power of 23 in 1 plus x whole to the power of 22 into 1 plus x whole to the power of 23 is nothing but I need to get, correct, I need to get sum of x powers as 23. How do I get? If I take from this one 22c0, I need to get x to the power of 23 from here, which is nothing but 23c23, correct? If I take 22c1 from here, which means only x term, okay, then I need to get 22x x to the power of 22 from second one, which is 23c22. Okay, so similarly power of the r1 value of this one will go down, r1 value of 22c r1 will increase, r1 value will increase, 23c r2, where r2 value will reduce from 23. Okay, now this is nothing but exactly what is given here. Okay, what is asked in the expression. So that means this is nothing but x to the power of 23 quotient in 1 plus x whole to the power of 22 into 1 plus x whole to the power of 23. If I combine these two, this is nothing but 1 plus x whole to the power of 45, correct? So what I am looking actually is x to the power of 23 quotient in 1 plus x whole to the power of 45. That's what I am looking at, correct? Now this is simple. This is a simple binomial equation, power 45, and I am looking for quotient of x to the power of 23, which is nothing but 45c, correct? 45c23. So my given expression is nothing but 45c23. This is the answer. And one more similar question came in JEE 2023. Similar question based on this. There I solved it using charts. There I didn't explain how you actually derive. I just mentioned for this one, this is the formula you should use. So basically 22 plus 23 and then R value, okay, which is 23. X to the power of 23 you are looking at. So because 23 terms are there. Okay, so you can use this way to solve that problem also. There I just use the formula. Okay, so the answer is 45c23. This is the answer. Next. Yeah, thank you. That's all. These are the some of the critical problems from binomial. Binomial theorem is a very fairly easy problem, easy chapter actually. If you solve all these problems and this some of these little complex problems, I think you should get 100% in binomial theorem. You will definitely get one or two problems in binomial theorem. Okay, so, thank you.